This is the second part of lecture 5. In this video, I address recursive functions. After this lecture, you can explain what recursive functions are. You can describe the execution of a recursive function, and you can also develop recursive functions. First, pause here for 2 minutes and try to answer this question. You need to write a function that gets a positive number and returns its factorial. You need to raise a customized exception if n is the given number is 0 or lower. And you also need to write a code that gets a number from user and uses the function that you wrote down for part A in that code to return the factorial of the input given by the user. You also need to handle the customized exception. And note that no module is needed to be be created, so you can have everything in one file. Here is the answer to this exercise. I wrote this answer using for loop. As you can see here, if in the function, if the given value, the given argument is lower than 1, then a customized exception is raised. And then I use a for loop to calculate the result, the outcome of this function. In the main part, which is written by the front-end programmer, in this case, you are both the front-end programmer and the back-end programmer. You get an input from the user, then you try to print the result of the function, a function that is given the input by the user. You enclose that in a try except because you know that a runtime error can happen. This is the second answer. I use while loop to do the same thing, so there's not much difference between the two. Doing the previous exercise shows that you can learn recursive function now. A recursive function is a method for solving a problem. It's a function that calls itself. This can happen either directly or indirectly. In the direct part, as you can see on the left side, in the code on the left side, you see the function f is called inside the function again. So that's the direct version of recursive functions, but we can have indirect recursive function as well. As you can see in the code on the right side, function f calls function g, and function g calls function f. So this is also a recursive function. How can you create a recursive function? I'm going to explain that using the example of factorial. As you already know, 4 factorial is equal to 4 times 3 factorial. 3 factorial itself is equal to 3 times 2 factorial. 2 factorial is equal to 2 multiplied by 1 factorial, and 1 factorial is already 1. So if I want to write down this using mathematical functions, I can say that fact4 equal to 4 times fact3. Fact3 is equal to 3 times fact2. Fact2 is equal to 2 times fact1, and fact1 is equal to 1. That's how you turn the first mathematical expression to an expression that can also work in a way for Python. Now it's time to turn this into a recursive function. So what you need to do is to always start with the expression that you do not see the name of the function is repeated on the right side. Here is fact1 equal to 1. So what I'm going to write down is if n equal to 1 as the input for the factorial function, then return 1. Then you put down an else part, or because return is always end the function, you can also just keep it as it is. You don't need to write down the else part. And then you try to find a pattern on the left side and write it in the code. So here you see that if I replace 3 with n, then I can write down fact n equals to n times fact n minus 1. So I need to return exactly what I see there. So that's why you see return n multiplied by fact n minus 1. And then you can add raise exceptions if you want to. So that's what was asked in exercise 0. And of course, you can add the don't remain part to see the result. You can use try except to handle the exception, the runtime error. Note that again, it is vital to have this if part at the beginning of the function before calling the function again inside the body of the function. Otherwise, if you don't do this, otherwise you will create an infinite loop, a loop that never ends. Now that you learn how to develop a recursive function, I would like you to also learn how a recursive function is executed. Let's keep the example of factorial in mind. Assume that in the main body of the code, I have I equal to fact 3. So fact 3 must be executed and an outcome should be created, and the outcome should be used to set I with. Fact 3 will, of course, that means the Visual Studio Code has to go to the definition of the fact and try to run it. So n is replaced with 3. Since 3 is not equal to 1, so it goes to the else clause, and in the else clause we have returned 3 times fact 2. Now we need to figure out what's the outcome of fact 2. So again, the definition of the function is found by Python, and this time n is equal to 2. Fact 2 is going to be executed. Again, 2 is not equal to 1. It goes to the else clause, and we have returned 2 times fact 1. Again, we have Python has to find the signature of the function and execute the function for the input 1. So n is equal to 1. This time the if clause has a condition that is true, therefore return 1 is executed. As a result, because fact 1 is now created, the previous return statement is turned into return 2 times 1, and the result is calculated. And that means that we can calculate the first return statement. We can figure out the result of that. That means return 3 times fact 2 is turned into return 3 times 2. And that means that 6 can be returned as the outcome of fact 3, and I can be set to 6. To see the visualization of this execution, please go to the address that I place here, copy the paste code, copy this code and paste it in the text box and click on visualize execution so that you can see how things work using that as well. Again, let me repeat that you need to always check the if clause first and call the function again after you check the if clause. If you try to execute this code, you will see a recursion error by Python, as Python correctly predicts that this code is going to be executed until the end of the world. Okay, let's now try to pause here for 2 or 3 minutes and uh, create a function, a recursive Fibonacci function. As you can see here, if the function gets 1 and 0, it returns exactly 1 and 0 respectively. However, the third uh, item in the Fibonacci is the sum of the previous two elements. So the third item is 2 because 1 plus 1 is 2. The fourth item is 3 because uh, the sum of 2 and 1 is 3. And the eighth item is 21 because the sum of 6 and 7th element, 8 and 13, is 21. So if you want to create this, you need to know that fib8 equals to fib7 plus fib6. Fib7 itself calls fib7, which means fib6 plus fib5 should be calculated. Fib6 itself calls, again, fib6, which means fib5 plus fib4 should be calculated. That means fib4 plus fib3 must be calculated. That means fib3 plus fib2, and all the way to see that fib1 equals to 1. So fib0 is equal to 0, and then, things can, as you saw previously. In this slide, you see the solution to exercise 1. Again, you need to start with the parts of this pattern that has, fixed part on the right side. Where you don't see the name of the function again. So you're going to write down like if n equal to 0, then return 0, else if n equal to 1, return 1, and then now you can write down the else part. And what you need to do is to just choose one of the operation there here, fib8, replace 8 with n, and then try to uh, create the rest of that. So fib n equals to fib n minus 1 plus fib n minus 2. So you need to write down exactly that in the return clause. Okay, let me show you again how the execution of this Fibonacci is being done. Assume that I equal to fib6 is being executed. That means since 6 is not equal to 0 or 1, that means the else clause must be executed, which means fib5 plus fib n minus 2, which is fib4. You need to take into account that fib4 is not going to be called. As soon as the function sees fib5, it leaves the rest of the expression and just try to focus it. Python focuses on fib5. So fib5 to be calculated, again, 5 is not equal to 0 or 1. That means return fib4 plus something. So again, the focus is on calculating what fib4 is, and this goes on and on. So what I would like you to note that the second part in the operation in the return clause, fib n minus 2, is not called until a value for the first part, fib5, is created. So let's see how this execution happens. Fib6 to be calculated, that means fib5 must be calculated first. So we don't care about fib4 at this stage. To calculate fib5, we need fib4. To calculate fib4, we need fib3. To calculate fib3, we need fib2. And to calculate fib2, we need fib1. Now we have a kind of return value, which is 1. 1 is returned to the function fib2. Fib2 has this value. Now it can calculate fib0, which means, again, 0. Now the return clause in fib2 is completely executed, can be completely executed. 1 plus 1 is 2, so 2 is returned to fib3. Fib3 has the reason for fib2, but it also requires the result of fib1. It's stupid. It cannot figure out that, this code is already being executed. So it's going to call it again, fib1, and then 1 is returned. 1 plus 2 is 3. Now we have the result of fib3 that is going to be returned to the function fib4. So 3 is returned to fib4. Fib4 to be calculated, it requires both fib3 and fib2. So again, all those things should be done so that 2 is created, and then the combination 5 is going to be sent to fib5. And then, again, we have to do the same thing for fib3. So 3 is returned. Now we have an 8 here. For fib6, we also require fib5 and fib4. So again, all those execution must be done so that fib4 is calculated. 5 plus 8 is 13. Now 13 can be returned, and I is set to 13. So you see, using recursion be uh, uh, can be inefficient. So in comparison to the for loop, but sometimes it's it's the only way to or it's the easier way to write a code. So let's do this exercise now. You want to search in an array for a value that is search in a list for a value that is given to you. Um, if you find the values in the set, for example, here if we are looking for 4, we see that there are 3 4s in this list. You need to return the indices of these 4, which is 1, 7, and 10. If you do that for 5, you see that 5 is in the indices of 2 and 8, so a list of 2 and 8 must be returned. So first, try to create a function using for and while loop, and then try to create the function using recursive uh, operations. So here is the answer to exercise 2. I used loops to search in this list. As you can see in the function, in the definition of the function, I created an empty list, answer index, and then I try to traverse the list using its index for I in range 0 then A. So if AI is equal to X, that means, I need to store I need to append I to the answer index place. And after that is done, I need to return this answer index. So again, the way that it works is that it checks the first item, A0. Is A0 equal to 4? No, it's not. So we're not going to do anything. So then we go to the next item, A1. Is A1 equals to 4? Yeah, that's correct. So we are going to do answer index.append I. Then we go to the next one. If AI equals to 4, no, it's not. So, and the rest is history. You can also use a recursion to provide an answer to this question. What you try to do is that you only focus on the first item in the list. If that item is equal to X, the given number that you're looking for, you append that, the index to the list. Here, keep that in mind that answer index and I are both global variables. Uh, so, so again, if For example, here we are looking for the 4, the value 4 in the list ARR. So as you can see here, we start with the first, with I equal to 0. We check if this item is equal to 4. We see that it's not equal to 4. Therefore, we are not going to add that to the answer index. After that, we need to check if the len of A is uh, greater than 0. That means there are other items. If that's not true and A is quite big, then um, we need to check uh, the rest of the storage boxes in this uh, list. So that's true. So we need to call the function find indices for the rest of the function. We are going to add 1 to I so that I is increased to 1. And then here I call the function find indices again for A, which an A, the array list A, the list A whose first item is removed. That's why we put one column there so that we can get the subset of A that does not include the first cell, the first storage box in this list, the first item in this list. So again, find indices is going to be called for this list A1 column, and we check if A0 equal to X, and that's true, yeah. So we need to append I to the global answer index list. And we are going to do that. And then since the list is still bigger than the size of the list is bigger than 1, we need to call the function find indices again, and this time again we remove the first item, which is 4. What we do is to again use a 1 colon, and again we check if the first item is equal to 4. It's not, so nothing is going to be done, and the rest is history. So you need to copy this code and execute this line by line, either in Visual Studio Code or in the tool that I show you a few slides back. What happens is that at the end, we only have one item left in the list that is given to find indices, and that's the last item. We see that for a 0 is equal to 4, that means I needs to be appended. Since here again, len A is, the size of A is lower than 1, then the return function is executed and the program ends. In summary, we learned that recursion occurs only when a function calls itself either directly or indirectly. It makes programming easy, but not necessarily uh, efficient. And you need to be cognizant of where you put the condition that stops the recursion. You have to always put it at the beginning of the function or at least right before you call the function again in the body of the function. If you have any questions, please ask them during the interactive lectures.